Okay, what I'm going to talk about is some next generation technologies and how it can be taken advantage of, particularly with students and getting them interested not only in technology but in the sciences, but in also driving it into other areas because not every student's going to be a scientist, not every student's going to be an engineer, but a lot of students are going to create things. And one of the things that the technology we are working in is a new way of creating things, and I believe it's a way of really opening up the opportunity to innovate, and being able to innovate and create is really what what students really like. I mean, the high school kids that I work with, I mean, that's really what gets them excited about these things. Cyberfactoring is kind of a term that we came up with because we believe this is the future of making things. If you look at the term manufacturing, it's a very old term. It's really derived from manual or by hand, and factoring is to make. So what we're looking at is the new way of making things. And so we took that name because, you look at it and you say, what is that? And that's really a question I like a lot because that's how I get people to think in other ways is to, what is that? And so kind of my affiliations that were mentioned is Cypher is a parent company. They spin off companies. One that's not listed is Vax Design was recently purchased by Sanofi Pasteur in the biology field. And then Anscript is a manufacturing, they build manufacturing equipment. So Cypher is really my home base, and that's where we really take core technologies and develop new technologies and spin those out. So what I'm going to talk about is printing. We all think about printing, in when you say the word, you think about it in different ways. Printing has a long history of um, communicating ideas. And really, that's really what printing was, is to communicate ideas, whether it was in the newspapers and so forth, or the printing, the printer that you have in your office or in your home. So if you think about a typical inkjet printer, what does it do? It really puts down mixes of inks. I mean, you got cartridges, they're all different inks, different colors, and they mix them to give you an image. The printer really doesn't care what it prints. I mean, it's really digital information. So we talk about digital media. That's really the area that I work, is digital media. And so when we tell the printer to go off and print something, it just does it. And print page one may be different from page two. It doesn't care. When you buy a printer, you basically look at it pages per minute. It's really the metric that you go by. But imagine, if you will, now, okay, I printed a page. That's just basically a 2D piece of paper. What if we could print in 3D? And really, that's what where we work. And if you look at 3D digital printing, what you're trying to do is develop technologies that's going to print in 3D. Again, the printer itself doesn't care what it prints. It just prints it. And how do you manage that? Well, you manage it with really cartridges of goo. And that the various cartridges of goo may be ceramics, it may be metals, it may be a number of different types of materials. But then how can create an object that you can hold in your hand? And the ability to hold it in your hand is really where the power is from a student's point of view, because they can imagine something and they can look at the theory and they can look at books, but if they can literally print it, hold it in their hand, that's pretty powerful. So 3D printing, it's been in the news. Florida Today's have had a number of articles on 3D printing. And really the history of 3D printing was to be able to do models and mock-ups of something that you were going to manufacture. It wasn't really the manufacturing process. It was the way to make the mock-up, if you will, of whatever it is that you're trying to fabricate. So with new materials, we're really moving into the ability to print products and print things that you could actually use. And so The Economist really is looking at 3D printing really in the digital realm as being the next revolution in manufacturing. And there's a lot of people that believe that. It was even mentioned in the State of the Union address. And there's a lot of money that is now really moving into that field. Now, if you look at printed electronics, that's the ability to really print functional type of devices. And some of these products you can get online where you have T-shirts, you hook it up to your iPod, and it basically gives you the frequency spectrum of the music you're playing. It's pretty cool stuff. Electroluminescence, like the butterfly that you see, the product packaging, you don't see that yet, but it's coming. You know, the way manufacturers want to get your attention is how they package their products. And so they get very imaginative in the graphics that they do to be able to get your attention. One of these days, you'll see boxes like that will, when you walk by, will start lighting up. Actually, will talk to you, say hi, those kinds of things. But what, you know, and that's very interesting from a graphics point of view. But what if you had a package like your carton of milk that had a sensor in it that told you your milk is bad? Well, you say, well, I just look at the date code. Well, manufacturers hate date codes. They throw away about $1 billion worth of food because of the date code. It's a statistical number, and it's based on a lot of factors. And so a lot of really good food, you know, basically when I go in and open up the milk, I smell it. If it's okay, sometimes I make a mistake, but it's okay. But if I can open up the refrigerator and it's got a red light and says, my milk is bad, well, that saves them a lot of money because it really is detecting the actual product itself. Or if your package of chicken has salmonella, that's pretty important to know. You don't know that till after you eat it, and it's too late. But if the package can tell you these things, it helps you, the consumer, but also helps the manufacturer because they save a lot of money. 3D printing. Again, you can go online and you can see these kinds of things. These are all three-dimensional, what I call mechanical pieces. The area that I work is in the electronics field, but the idea here is that you can be very imaginative, you can innovate, you can really imagine new ways of fabricating something because now you have a way of spatially controlling materials. Well, the artist doesn't care if they're spatially controlling materials because they're going to make a shoe. That's what they want. They can create it to whatever shape they want or whatever fabric or whatever color. The other thing is in music. I presented this to a music class at Bayside, and they got pretty fired up about this. There is the MIT website. They show you, they have a YouTube thing that shows you where they 3D print a flute. Well, you know, that's interesting. Well, flutists know that when they go to the store to buy a flute, it's certain length, it's certain color. There's not a variety of things that they can choose from, so it's basically one size fits all. But what if your hand is shaped just slightly differently and it prevents you to play a flute, but you want to play a flute? Well, maybe you print yourself one that's personalized to you. That's the other power of 3D printing, is you can personalize whatever it is that you're doing. Again, the ideas and the innovation that gets students excited, because maybe you want to invent a new way of doing a bugle. I don't know, you know, it's just an idea. But where I believe the power and the killer app in this technology is going to come from the artistic side of the world here. Film and animation. A lot of your newer animated films, they actually 3D print the characters. Because the old way of doing it is they do clay models. It's very time consuming, very expensive. They're on schedules. They don't have time to innovate so much because they got to get it right the first time. But if you could 3D print it within a few hours, then you can kind of play around with some new ideas, new ways of thinking, new ways of innovating. But then at the end of the day, you come up with a pretty interesting product. So the other area is medical. This is a big area. Think about prosthetics. You know, a lot of prosthetics that you see are very mechanical, metal-oriented type things. It's not very aesthetically appealing to particularly the person that's wearing it. So imagine, if you will, with the lady up upper left here, she wanted something more aesthetic. So you actually 3D printed the prosthetic that's a little bit more appealing, and it's personalized to her. Again, personalization. The man at the other corner, they 3D scan his right leg. And then they take that image and print his left leg. Again, you're able to, it's still mechanical, but they're able to at least match, and it becomes not obtrusive in a visual sense, so they feel more comfortable with that. 3D printing skins, you can go to a lot of dentists now have adopted 3D printers and can print your teeth. Again, personalized to you. Very hard to manufacture that way. They basically have sizes and they kind of fit you in somewhere. They're not very comfortable necessarily until everything kind of moves around. But they can personalize to you. I work with University of Texas, El Paso. They do a lot of, they take MRI images, x-rays, and I had an example, I don't have it with me, but they had a patient, the surgeons come to them, they had a patient that had a tumor in the jaw. So they basically took these images and were able to print the jaw, print the tumor in a separate color. So the jaw was clear, the tumor was red. So the surgeon now has something to hold in their hand and do surgical planning. Something very hard to do just on images. This is something that's real, they hold in their hand. They can also see where the tumor is going. So they can go in and clean it out. And oh, by the way, they have a digital image of what the hole is, because that's where the tumor was. And you go print a ceramic scaffold that gets inserted, as opposed to pulling bone from your hip for replacement, and then basically a graft. So it's really interesting, powerful technologies. So when I show students this stuff, they get very excited, especially this one, because this is a bald eagle that somebody decided they want to shoot. He survived the attack, but what they were going to do is put him down because he couldn't eat, he couldn't drink, he had to be hand fed because he didn't have the beak. He couldn't groom himself, and so it was a 3D printing company was made aware of this, and they actually then 3D printed the beak. They attached it. It's still under captivity, but it lives. It's able to drink, it's able to eat, take care of itself. So again, but the 3D personalization to the eagle was pretty important to the eagle. Again, students see this stuff, they get very excited. Disney, they're playing around with 3D. You can go in with their new Star Wars attraction and get yourself scanned, and then you can carbon freeze yourself. So while you're out playing, they'll print you out an image or print you a souvenir that you carry out with you. And they do the same thing with dolls. You can actually have a facial scan, and they put your head on a doll's body. So so then you look at other potential products. These are things that, again, you go online and you can get. There's websites called like Shapeways and other places where they have downloadable 3D software, and you can kind of design your own little 3D widget, print it, and they actually have a storefront that you can sell your products that way. And a lot, you point that out to these kids, they get pretty excited, and they start designing things they never imagined they would have designed. They're doing CAD drawings that they're not really thinking about, I'm having to learn CAD. No, they're thinking about, I get to print myself one of these things. And that's really what they get excited about. Okay, printed circuit structures. That's really the field I'm directly in. Everything I've showed you in the past were really mechanical objects. So they had mechanical functions, but that was pretty much the limit of what they did. So what we do is really are adding the electronic functionality to it. So we've been developing technologies for your basic electronic components so that you can build things that now have electronic functionality. These are some examples. Unmanned air vehicle wing structure, where you basically print the wing, print the sensor that's on the wing, and so it can basically measure what's going on with it. Magnetometer, again, it's 3D printed. And what we do is we place what we can, or print what we can, place what we can't. There's a lot of electronic components we cannot print yet. It will happen. So we actually have pick and place. And so the whole idea is with a button, you sit there and build these things. There's an accelerometer, it's a vibration sensor, and what that does, you put it in a helmet, it measures impact, and it actually has an antenna, and it will transmit the data. Bottom middle is a dice. We had a booth in Las Vegas, so we created these dice that we printed up, and they light up when they're bouncing around, and when they stop, the side facing upward lights up. So it's got sensors and detects that. All right, the iPhone. This is my favorite example. This is our goal in life, is to print one of these. And we are talking to DARPA right now about that. Everybody has a smartphone. I have an iPhone. Everybody has a smartphone. And what's different between yours and mine typically is like the case that you put on it. You personalize your phone. The other thing that's different is the apps that you put on it. And so whatever things you download, that becomes your phone. This is you. It has all your information. It has everything that you like is on this. So it's very personal to you. So imagine, if you will, if you take iPhone and create my phone. So maybe you want your phone to look something like this or something like this. You now can create something that's a little bit different, and again, personalized to you. So how does this play into what I do at the high school? Well, the technology is cool, for one. It's something that people can hold in their hand, is two, and they get to play. And when you get to play and learn at the same time, you get very passionate about what you're doing, and that becomes careers. So STEM, we all know what STEM is, but we like to add the artistic side of it. When I actually went in Bayside High School, I didn't go into the beta class because they're already engineers. They know what they're going to do. I went into the digital media group because that's really where all this comes from, is digital media. You're printing things. So I started talking to those students and some of the drafting students that were learning CAD, and they were dreading learning CAD, but I'll show you some examples of what come out of that. If you look about, I like Einstein, and I like the imagination part of it because I like thinking out of the box. I like pushing people to think out of the box, and then look into adjacent technologies and really kind of create something that's new and different and novel. If you look at history, a lot of innovators were artistic. Da Vinci, his only limitation was the manufacturing process and the materials available. His limitation was not in his mind. It was in the process. So we get into 3D, we're now being able to pull out some things because you're now being able to fabricate stuff you've never been able to fabricate before, because now you control spatially different materials. Again, the students don't know what spatial is yet, but they're learning. And but what they do care about is what prints out of the machine. This was a group of students that, this was the first group that I worked with, and they were the ComTech class. And one of the things that they had in their classroom is a screen printer. Well, what do they use screen printers to do? They print T-shirts. So people come in, they can order T-shirts, and they do the designs, they do the artistic side of it, and they would silk screen T-shirts. And they also use the digital inkjet printers to make posters. And so they do a lot of graphics things. So I said, well, what if you could animate your poster? And they said, what do you mean? I said, what if you can make your poster light up? And the software they use is Adobe Illustrator. It's not an engineering design tool. It's a graphics tool. Well, what they did learn, because I did electronics 101 with them, is learn what a wire or a conductor is, what a resistor is, and what an LED is, a little light emitting diode. That's all they needed to know, and a battery. That's all they needed to know. But what can they do with that? They can light up their posters. So what they ended up learning how to do is draw conductor layers. So they were talking about, here's my graphic layer, here's my conductor layer, and so forth. And they just knew enough to light that LED. But what they did do is create this poster that showed how they made the poster. So Bayside Bears is their mascot, so they did a graphic bear, and the bear did each part of the process as they get to the end. Well, we had little LEDs that follow the footsteps, and it got animated, so the LEDs light up. And then I took them to IMAPS, one of our conferences, and they had a booth, and they were able to display this thing and really talk to practicing engineers. And these are artists, but they were getting pretty fired up about a new way of doing graphics. Because one of the things you'll see is a lot of graphics companies will be converting into electronics companies. Well, the graphics kids, students, they don't know that, and they don't even know what the electronics is about. They get exposed to that. They can go to a graphics company, and when they're moving into this technology, whether it's the packaging or whatever, they have a handle, or at least a basic understanding of what the technology is about, and they can move as the technology progresses. Okay, this one, they have a 3D printer. It prints plastic, and so again, they were just making mechanical parts, and I was going to bring that with me today, but it was spring break last week, so I didn't get there in time. But what you have is a roulette wheel, and then we created a circuit. There's a lot of apps out there. You can download circuits that do certain things. So they downloaded one, and then they did the circuit board, and then they used a 3D CAD tool and then designed the roulette wheel. And then we added the circuit board, and when you hit the button in the middle, lights basically give you the illusion that it's rotating, and then the light stops at a number. And so that was pretty cool. I took them to a conference, and they were able to show that. The student that's standing there, he was a junior at the time, got an internship that summer at Harris, because we had Harris people showed up at our booth, and it was a paid internship for a high school, which is pretty good. His teacher, before we all started, she said she didn't know what to do with him. He didn't have any direction, didn't know what he wanted to do in life. Well, the following year, I wish I had a picture, I don't, is his science project was he developed a little machine that ground up plastic bottles, and then he got the little heater, kind of like you would for a glue gun, and was able to melt the plastic, and he was able to print little objects. It was very coarse, but the whole idea was to take plastic that you threw away, grind it up, and make a product from it real time. Very cool. He went to state with that project. So again, really getting them to imagine, because the power of it is being able to touch it and to make it and see it. And so this past few weeks ago, we were at a conference, and I had this group, and they did a smartphone charger. Basically, you would put your smartphone in there. It's a little solar charger they added speakers to it. And so you could trickle charge your iPhone and it play music. But the holder itself was 3D printed. So they designed the whole assembly and did 3D models of it, and then were able to print the individual pieces, assemble it, and then we've displayed it at the conference. We had the director of NASA stop and had a long discussion, and actually talked about 3D printing when he gave his keynote addressing them, which was very cool for them to see and experience. So now they're thinking about what the next generation of this product's going to be and what they want to do, because we're going to go to a conference in October. So They're already brainstorming the next widget that they want to build. But all this work was done on their own time. We meet before school, they come in, we brainstorm, they brainstorm, and then come up and then start creating things. And again, it gets them excited, and it's something that actually helps them learn, because they have to, in this class, they were learning 3D. And so rather than going through an instruction book to learn 3D, they are actually fabricating and building it. So that's the end goal for them. So the process of learning is really the process, and is something that they don't think about as, I got to learn this, but I'm going to print this, is really what it's all about. The future, okay? One of these days you're going to go into your dealer and you're going to pick out colors and all those kind of good things that you want your car to be, personalize it to you, and then while you're filling out the contract, they're going to be printing you a car. Is that going to happen? Yes. Rolls-Royce right now are printing ceramic engines. They're not in production yet, but they are printing ceramic engines. Boeing is doing a lot of 3D printing in pieces of their aircraft. I work with them on a few things where our goal is to print a little micro with embedded sensors and all those kinds of things, and literally print the whole device. So that's where we're going. And this was a conference that was a few weeks ago. That was the one that that they took the iPhone charger to. You can see the keynote was Director of Engineering out of NASA, who spent some time with them. And then I have another conference that I'm heading up, which is in May at summertime. Students are always talking about attending this, and this is summertime, so they're going to take some time out of their fun activities and go do this. So, and that's it. Any questions? Yeah. How much do printers cost? 3D Systems you can buy one for around $2,000 that you assemble yourself, but it works in plastics. If you're talking about titanium, it's about $1 million. So it's a wide spectrum. Nscript, which is a company I'm affiliated with, we're doing multi-materials. They range from 100K to upwards of $1 million. But again, there will be home printers. If you recall back where they had document centers, which is where you went and had your documents printed because you didn't have a printer in your office, some of those machines, when in the early days, were quite expensive, particularly the production printers. In fact, some of the inkjet production printers today are still quite expensive. But if you're able to manufacture, and one of the programs we did with DARPA was called high volume manufacturing in quantities of one. What does that mean? Well, that means I can do 100 different products all on the same production line. Because again, it's a printer, so page 1 can be different than page 2. Widget 1 can be different than widget 2. The other part of bringing the manufacturing process here into the United States, which is very key, is the personalization aspects of it, or the regionalization. Because if you go to the store and say I'll use Christmas ornaments because we spend $1 billion to China to buy Christmas ornaments. You go in, you pick the colors they have on the shelf. If you can imagine printing whatever it is you wanted, your alma mater as a bulb or an ornament, you could do that. You can't go to China and do that because they only build lots of page 1s, is what I say. We want to build multiple pages, so that's where I think the power of the technology is important for this country. So. Yes, like the one student took plastic bottles and ground them up, melted them, and then reprinted with them. I mean, there are certain limitations on some plastics because they degrade. That's why some of the product packaging, they have those little numbers on that are molded in. It tells you what can be recycled, what cannot. And it's really the degradation of the materials. But in general, yes, titanium, you grind it down to powders and you can reuse titanium or aluminum, copper, those can. That's the other thing. We say it's green. It's a green process because you're printing what you need, not taking a big block of metal and machining away what you don't need.